Hi everyone. Today we're talking about a very important concept from SQL and from any other database, or even in Python. Also, when you're joining data frames, that is joins. So we'll be discussing out five type of joins, that is inner join, outer join, left join, right join, and cross join, using some examples. And this is very important interview question as well. So I think let's get started. Let's understand how joins work. So first of all, I will be explaining about the dummy dataset that I have. I have two datasets. One is names, which consists of two columns, ID and name of a person, as you can see, and other is address, which again consists of ID and address. You must have guessed it that we will be performing all the five types of join over this column ID. Now I have made slight changes in this particular dataset. So in case of names, we would be having IDs from 1 to 50 and 100 to 150. So I have missed out on 50 to 100. And in case of address, we would be having IDs from 1 to 100. So both the data sets have 100 samples, but IDs in case of names is ranging from 1 to 50 and then 100 to 150. And we have ignored the period from 50 to 100. And in case of address, the IDs are continuous from 1 to 100. So now we'll be understanding all types of join, starting with inner join. So basically, in case of an inner join, what happens is that whenever until unless we find a match, only those rows would be considered, and rest of the rows will be ignored. So we would be ignoring. We don't want to jump into the codes. Basically, it's just a concept I want to explain. So when I would be doing an inner join over the column ID for these two databases, the expected number of total samples is just 50. Right. Let me tell you why. Because as I told you that the ID column in names ranges from 1 to 50 and 100 to 150. And in case of address, it ranges from 1 to 100. So the common set of IDs is just 1 to 50. Right. So there would be 50 rows that would be finding an exact match with an ID in address. So in that case, we would be in the final join, after joining these two tables over using inner join over ID column, the final output has just 50 samples. Now talking about left join. So in case of left join, the catch that comes in is that the table which is coming first. So in case, as you can see, that pd dot much is basically used for joining in data frames in pandas. So the left is names and the right table is address. So in case of a left join, what happens is that any row that doesn't find a match in the right table, that is the address table, will still be considered in the output, but any row from the right table that doesn't find a match in the left table won't be considered. Right. So you must have guessed it right. When I would be joining over ID column for names and address, all the IDs that are present in names would be present in the final output. So we would be getting all the names that are from the range 1 to 50 and 100 to 150. The whole names table would be present, but in the address table, whichever rows are not able to find a match in the names table would be ignored. Hence, the total samples would be equal to the size of the names table. And here you can see that the output. So whichever names hasn't find a match in the address table. So as you can see that 146 147 IDs are not present in address, as I told you that because the IDs in address table range from 1 to 100. They didn't find a match, hence the value for address is nan for them. But the whole names table would be present in the output, but this won't be the case for the address. So the rows from address table that didn't find a match will be removed. Now, right join is vice versa of left join. What we saw above is that all the rows from the names table were considered because it was a left table. In case of a right join, all the rows from the right table would be considered, and the rows in left table that don't find a match in the right table will be ignored. So if you see, when I do a join on the ID column for names and address, the total number of samples generated is 100, still 100 because the size of both the tables was same, 100 samples. But here you can see that for IDs 96, 97, 98, 99, these IDs don't exist in names table, as I told you earlier, because IDs range from 150 to 100 to 150. 50 to 100 range is missing for names. So in this case, you can see that the names are nan, but address are coming up. So all the entries from the address table are considered, but not all the entries from the names table is considered. Now moving on to the outer join. So outer join will consider all the rows from both the tables even if they don't find a match. So the final output would be 150 this time. So this is a bit tricky to understand. Let's pay some attention to it. So first of all, we would be having 50 rows that would find a match as we saw in inner join, right? Now there would be another 50 rows from the left table names that won't find their IDs in the address table. So again, they would be considered in the output, and there would be remaining 50 rows from the address table that won't be finding a match in the names table. They are also considered in the output. So an outer join can be taken as a union of output of inner join plus left join plus right join. So when you do a union over these three join, eventually you get an outer join only. So here in the output, you can see that we have generated 150 samples. I've explained you the reason why. And you can in the output you can see that we are having rows where address is present but name is not present because these IDs are not present in the names table. Similarly, we are having entries where name is present but address is not present because these IDs are not present in the address table. And we are having entries where both are present, where we found a match also. So it's a union, as I told you earlier, of inner join, left join, and outer join. Now the last type of join, that is cross join. Cross join is the easiest to understand. So it's basically nothing but joining each and every row from the first table to the next table. So the total outputs that we generate in cross join is 10,000. How come? Because what will happen is that for every row in second table, we will be joining it with every row in the first table. So for example, as remember, both the tables have 100 samples. So for the first row in names table will be joined to 100 rows of the address table. The second row of the names table will be again joined to the 100 rows of the second table. The third row of the names table will be again joined to the 100 rows of the address table. So every row will be joined with every row in the second table. Hence, basically the output of a cross join can be estimated by n cross m, where n is the size of the first table and m is the size of the second table. You can see that when we do a cross join, Lisa Lewis is getting cross join in all the possible address in the address table. Similarly for Janice Collins, whatever the output that we are able to see here, and hence the output is 10,000 rows.